All right, so 3.7, modeling using variation. So we have these variation problems, or we have these applications that we'll be using variation in order to solve. So there will be other ways that you can solve these equations or these problems, but this section focuses on using variation. So just want to throw that out there. There will be other ways. If you know other ways of solving, yes, you could use such and such in order to solve certain problems, but we're using just variation in this section. So that's why we're going this route. So when it comes to variation, you will have key phrases or keywords that will dictate what type of variation you will use or how you will set up your problem. So the first one we're going to look at is direct variation. It says y varies directly as x, or y is directly proportional to x. When you see that key phrasing or key phrases, this is how we would set up our problem. Y representing the variable or the term that happens before the phrase varies directly. X will represent the variable that occurs after the phrase varies directly. And you'll see what I mean in a second. All right. And then K is your constant of variation. So while you write that, just point out the fact that K will be used throughout all of these problems. So there will always be a K involved. That's our constant of variation. X and Y, that just represents whatever variable we use. We can change those whatever we like. You'll see that, we can use D for distance, T for time. But what we don't want to do is use K for X or Y. In other words, if I had kinetic energy, I wouldn't want to use K because I have K as a part of my constant of variation. So I would use E for energy instead of, the K for kinetic energy. So just throwing it out there is, you'll see what I mean as we start to go through the problems. We're going to establish what our variables will be. You get to choose your variables, but what you don't want to choose is K because K represents our constant of variation. All right, so let's look at this first problem. The distance that a body falls from rest varies directly as the square of the time of the fall. If a skydiver or skydivers fall 64 feet in 2 seconds, how far will they fall in 4.5 seconds? So I'll give you a chance to write it down. All right. So we're gonna go through these steps. I've written out these steps. If you follow these steps, no matter what problem you deal with in this section, it should set you up for success. Step one is that we want to identify the variation setup. So we see right here it says varies directly. So that means we're going to use this setup of y equal to k times x. All right. Next, we want to establish our variables. Now, what comes in front of varies directly is our y. The distance that a body falls from rest is our y, and that's what comes in front of the equation sign. So D is going to be for distance. Up to you what variable you want. If you want to use W for distance, I don't know. It don't. It's up to you what you want to use for distance that the body falls from rest. Once again, I use D. It's best that you use something that connects you to that phrasing, but it's up to you. And then we see that we have time is what comes after varies directly, so I use T for time. Okay, so varies directly is our phrasing. What comes before varies is our first variable. What comes after directly is our second variable. And so we write down the equation using D and T instead of X and Y. So we have D equal to K times T squared. Also notice that it says the square of the time. So that's why we have T squared. All right, make sure we are okay. right. So now we're going to write down the given information. Now, what's going to be the pattern of every problem that you get out of this section is that they're going to give you a set of information, and then they're going to give you all of the information except for one piece. All right. So notice they give us D1 and T1. I call them D1 and T1. That's the first set of information, the distance and the time. Then they want us to know what is the distance if the time is 4.5 seconds. So they're going to give you all of the information except for one piece. It's not going to just be two, sometimes maybe three or four, but they will give you all of that in the first set. And then once again, everything except for one piece in the second set. All right. And once again, that problem came from, those numbers came from the problem. If you go back, skydivers fall 64 feet in 2 seconds. So that's where I got 64 and 2. Then how far is the fall when they fall in 4.5 seconds? So that's where I got those numbers from. So now step 5, use the equation in the first set of information to find K. So we're going to plug in D1 and D2 and solve for K. Questions? Any questions? Make sure we're all right. So now that we know K, we're going to take that 16 and plug it into the equation for K. Remember, it was dk right here, dkt squared. D is equal to kt squared. And now we have D is equal to 16t squared. Your K is your constant of variation. So that 16, that K is going to be 16 throughout the rest of the problem. And now for our final step, use the second set of information and the new equation to find the missing piece. So we knew what T was. So we plug T into the equation. 16 times 4.5 squared will give us 324 feet.
Could you scroll up? You went too fast on that one.
How far up?
A little more up to number 5, step 5. There we go. That's good.
Mm-hmm. So initially, these problems may seem long or sound like they're long, but that's because we're going step by step, pausing, and once you get in your flow, following the steps, they're not that long at all. All right, questions. All right, how we doing? Are we finished? Pretty good. All right. So the first one was direct variation. Here we're looking at inverse variation. Same type of thought process, just a little bit of different setup. Y varies inversely as x, or y is inversely proportional to x. So you notice now we are taking y equal to k and placing x under k for inverse variation. All right. Let's scroll up. Everybody good? All right. So when you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. In general, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. The pressure of a gas sample in a container whose volume is 8 cubic inches is 12 pounds per square inch. I'll pause right there and then get to the next piece in a second. All right, if the sample expands to a volume of 22 cubic inches, what is the new pressure of the gas? All right. So first step is establish what your key phrase is, and that's inversely. So we're looking to set up our expression or equation as y equal to k over x. Next, we want to establish our variables. So before inversely, you see the pressure of the gas in the container varies. So we'll use P for pressure, and it says varies inversely as the volume of the container. All right, so I use V for volume. All right, so now I use P and V to go ahead and set up according to our inverse variation. That's what we did right here. Don't forget K is always a part. K is always a part of our setup. All right, write down your given information. Pressure was 12, volume 8 cubic inches, I believe, cubic inches, yeah, cubic inches. And to say what is the pressure if the volume is 22 cubic inches. So we have all of our information in the first set. Then in the second set, we're missing one piece. Any problems? Now we plug in this first set of information into the formula to solve for K. So that's 12 equal to K over 8. Multiply both sides by 8. K is equal to 96. All right. Step 6, plug in K equal to 96. Plug in 96 for K into the formula. So that's P equal to 96 over V.
So, Professor Tucker.
Mm-hmm.
So basically, you're saying you do the reciprocal of 12 over 8.
What you mean? You said do the reciprocal of 12 over 8?
You put the 8 beside the 12.
Well, we're trying to solve, if you remove all this, we're trying to solve for K. So we have K divided by 8. So in order to solve for K, you'll multiply both sides by 8. You know, if I want to get 8, if I want to remove this 8 from the K, I will multiply both sides by 8.
Okay.
Oh, let me do that.
So the 12 don't take the spot of the K.
Say that again?
The 12 doesn't take the spot of the K?
No, we just solving for K. Same thing as if I had 5K equal to 12. In order to solve for solve for K, I would divide both sides by 5, right?
Okay.
Yeah, just taking it back to the same old school principle of undoing what's being done to your variable.
Thank you, Professor.
Yeah, not a problem. All right, so now we can go ahead and solve for P when V is 22, and that's our answer. All right, questions. All right, let's try it again, but first we have combined variation. That's when more than one variation is used. And then we're going to introduce joint variation. Similar to direct variation, it's just that you would be multiplying more than one variable. So y varies jointly as x and z. That's y equal to k times x times z.
So combined variation and joint variation is the same thing, right?
No, two different things, because joint variation is the same thing, is a whole separate variation like direct variation and like inverse variation. Combined
Okay.
variation is if you use direct variation and inverse variation at the same time. So,
Okay.
so you'll see in this next example. Yep.
Okay.
And so, like I said, the difference between direct variation and joint variation, direct variation just use one variable. So you have y equal to kx. Joint variation uses more than one. That's why you have x and z. So let's look at the centrifugal force of a body moving in a circle varies jointly with radius of the circle, a circular path, and the body's mass, and inversely with the square of the time it takes to move about one full circle. So you see here that we're varying jointly and varying inversely at the same time. So that's what we're talking about combined. So a 6-gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 6,000 dynes. And I'll move up in a second. All right. Find the centrifugal force of an 18-gram body moving in a circle with radius of 100 centimeters at rate of 1 revolution in 3 seconds. All right. So, important thing with this is not to get overwhelmed, just to take your time, walk through the pieces of the problem, look at keywords that's going to dictate what you should do, and go step by step according to steps I gave you. All right. So the first thing we want to look at, we want to look for those key phrases. I only gave you 3 of them. I gave you direct variation, inverse variation, excuse me, and then joint variation. So we have 3: direct variation, inverse variation, and joint variation. Those are the key phrases you're looking for. And you saw that this varies jointly and it varies inversely. And so that's what we have here. We're going to have to combine the joint variation and the inverse variation. All right. So before we do that, we do want to look at what variables we'll be using in front of our first varies. We see the centrifugal force of the body moving in a circle. So C will be our centrifugal force that varies jointly with the radius of the circular path and the body's mass. So I'm going to use R for radius and then M for mass. Then it says inversely with the square of the time. And so I'll use T for time.
Could you scroll up just for a couple, where it says 2 seconds has, yeah, that's it, that's good.
Pastor Tucker,
Mm-hmm.
question.
Mm-hmm.
In layman's term, for me, basically, I have a graph. I graph it, then I graph the inverse, then I graph both of them on the same document, on the same page.
When you say you have a graph, what do you mean by that?
When we're doing these formulas, we're looking for the graph itself, the inverse of that graph, and the joint of that graph.
Nah, I think you're going a little too deep with it, because
See?
you don't really have a graph that you can relate to in this case in reference to having a function and then an inverse function. You know what I mean? Because if I hear you correctly, you say you have a graph, then you said the inverse of the graph. Well,
Yeah.
really, all we're doing is using key phrases to set up the equation. In other words, direct variation sets my equation up this way. Inverse variation just says instead of putting the k beside instead of putting the k beside x, you're putting the k over x. You see what I mean? It's just those are just separate setups. They don't have any really connection to each other.
Okay.
You see what I mean? Like, yeah, so saying that one is the inverse of each other, that's not really what it's saying. It's saying that these relate, the way that y and x relate to each other is inversely, not necessarily to a whole nother function.
Thank you.
Yep. 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 Yep.
I wanted to make sure I had a concept correct in my head. That's all.
Yeah. Not a problem. So yeah, so when we talk about direct variation, we're talking about the relationship. So you can look at it that y relates directly to the x, if you want to look at it that way, wherein inverse, you know, uh, is relating to, because that's 1 over x, that's the inverse of x. So that's how I kind of look at it, division, inverse division, you have to put the x in the denominator. So I don't know if they help or not, but yeah, we're talking about a relationship between the two variables. All right, so now we are at step 3. So you want to plug in your variables for what we said that they relate to and what they mean. So that's C equal to K Rm over T squared. Remember, it's inversely to the square of your time. All right. So now we look at the given information. So we have 6,000 for our first C, 100 for R, 6 for the mass, T for the time. I said T for the time, 2 for the time, 2 seconds. And then in the second one, they give us everything except for the new centrifugal force, 118 and 3. All right, questions? Any questions? All right, so plug in all of the first information. So that's 6,000 equal to K times 100 times 6 times 2 squared. And remember, we're doing this so that we can solve for K. All right, so 100 times 6 over 2 squared reduces down to 150. Divide both sides by 150, and that'll give you 40 for K. All right. Plug 40 in for K. So that's 40 Rm over T squared. Now plug in all of the second set of information to find the new centrifugal force. And that'll give us 8,000 dynes. Questions? Any questions? All right. Any problems before we go to the next thing? Make sure we're good. All right, so that's it for variation. Let's see. No. So we are now looking at being done with chapter 3. It's 3.1 through 3.7. And we have one more set of new content that we have to cover that I know we have to get through, which is 4.1 through 4.4. So just pointing that out as far as what is what I know we have to cover in order to prepare you going to Pre-Calc 2. So if you look at the syllabus, there are a few more topics. That's more than that goes past 4.4. If we get there, fine. If not, it's still fine. But I know we need to do 4.1 through 4.4. So just letting you know that most definitely we have 4 more sections left to cover. But for this new test, 3.1 through 3.7, remember we didn't proctor the second test, and I told you more than likely we would be proctoring this one. So this is how I'm looking that we can go ahead and do this. Next class, I'll answer whatever questions you guys have. See what you guys want. I said then that test can be on Monday. I mean, unless somebody wanted it on Wednesday, unless y'all want to do it on Wednesday. Doesn't matter to me which day. But we do need to proctor, a test. And you never know, my math lab may crash on us again, who knows. But when we proctor it, your class is 12:30. But the way I was going to set it up is that the first time you take it, 100% is your option. You can get as much as 100%. But for the makeup, the highest you can get is 85%. Now, just reemphasizing that doesn't mean if you score 75, I will minus 15 from it. I'm not saying that. It's just saying that the highest you will get is 75. I mean, it's 85. So if you score 75, you get 75. But let's say if you were to score 90, then your grade would be 85. The cap on the makeup will be 85. And that's because you could have it around, at the most 3 shots of taking the test. The proctor test. Then once I post it in my math lab, you will get 2 shots to get the best grade possible. And also that gives how can I say it? I won't say illusion, but I use it for best case scenario, lack of a better term. illusion of having a proctored test, but then having to make up. So there's something to actually taking it proctored versus not taking it proctored. But as I mentioned before, if you do everything you're supposed to do, an 85 on the test will not stop you from getting an A out of the class. So really, is not preventing anything. As long as you do all your homework. You had 2 tests that were unproctored. So either way, this 85 will not stop you from getting an A on the test. I mean, A out of the class. What was the other thing I was going to say? And I forgot what I was going to say. Anyway, any questions? While I try to think about what else I was going to say about that. Questions?
I did have a question
Mhm.
on whether it's on Monday, Wednesday. Are you going to post an announcement, or are you going to poll?
Oh no, it's on Monday. I mean,
Okay.
unless nobody said anything else. I mean, so we rock it on Monday. We established that today.
Okay, cool.
Now, like I said, if somebody can give me a legitimate reason, or if we come in on a review day and questions just fill up the classroom, and I don't get a chance to, answer all questions, I'll consider, shooting it to Wednesday. But if if it's only 1 or 2 people, and then I have to find a question, just fill up time, and that lets me know everybody's ready. And so I always think the best out of everybody. So if no one has questions, I'm assuming that means you're good to go. But yeah, if you guys come with legitimate reasons as to why we should move to Wednesday versus Monday, then I'm all for it. I'm all for it. But yep. What else I was gonna say? Oh, also, if come Monday, you're just not ready for it. People have opted out and just went ahead to the makeup. I mean, that's fine as well. I'll be here regardless on Monday, ready to do the test. Whoever show up will show up and take the test, and whoever doesn't, then I'm assuming you're gonna wait until the makeup post, and then you're gonna take it as far as the makeup is concerned. So yeah.
Is the makeup proctored?
No. Nope, that will be you doing it on your own time. All right. Anything else? Anybody else? Everybody good? Everybody straight? All right. So, Mr. Coley had a question on a problem. So if you guys want to stick around for that, feel free to do so. If not, I will see you guys on next class for the review, and we'll go from there. All right. So you guys take it easy.
Hey, Mr. Turk, I do have one question.
Yes, sir.
So I'm in that like tutoring class with
Okay.
I don't remember what her name was.
Yeah, Ms. McIntyre.
Ms. McIntyre, that's what it was. And she told me that because I did the test review in her My Math lab. And she said she sent you an email about it. She said we got like 5 points on the test or something like that.
Yeah. So either she's gonna put it in my class manually, so I'll see it later, or I'll go to her class. So I don't add those 5 points till the final grading anyway. So
Okay.
Before everything's said and done, I'll make sure you get your points.
Okay, perfect. Thank you.
All
Yeah,
right,
'cause
not a
I've been
problem.
doing all the work in her class, so.
Yeah, she let me know that. So yeah, she has it. We've joined our shell. Well, I've given her access to my shell now, my math lab, so she can add those points and everything.
Okay, yes, sir. Thank you.
All right, not a problem.
And the homework is due all Sunday night?
I have it set for this Sunday.
No, I'm just wondering because the test is Monday.
Well, normally, but I do have the makeup that's sitting up out there. So I haven't really put a date out there for the makeup yet. So we'll talk about that. I haven't really put a date on it yet. So right now it's just open.
All right. Thank you so much.
Not a problem. You have a good one.
All right, you too now.
All right, Mr. Coley, what you got?
Can you bring up the book in my math lab?
Let's see.
Page 418, example 4.
All right, so now you're looking at it. Do I need to bring it up, or do I need to look up the book myself?
You bring up, I don't have mine up, that's why.
Oh, okay. You said it like you had it up.
No, I'm looking at my notebook. I wrote down the problem in my notebook. I got it written down in my notebook. I can hold it up to the screen.
Oh no, I have my book right here. I thought you needed to see it. Do you need to see it, or can I just open up my book?
can just open up your book.
Oh, okay. All right. Yeah. So, because that'll take less time. At least I thought I had my book. What happened to my book? All right. Well, I guess I had to go in there anyway. All right. Never mind. It must be over there somewhere, and I'm not going over there right now, so it'll be all right. Thought I had it sitting down here.
It got real today, Professor. It got real, and it hit the fan.
Excuse me.
Oh, Lord Jesus. Got me rubbing my forehead. I don't know if you can see me or not. Now with my degree major, I'm going straight from pre-cal to applied calculus.
Mm-hmm.
Is that normal?
Yeah. Now, if you were going to, isn't that analytic calculus? Okay, no, if you were going to calculus 1, then you would need pre-cal 2.
Because I'm going straight from taking this class to applied calculus.
Mm-hmm. Yeah. That, like I said, if you were going to pre-calc, not pre-calc, if you were going to calculus 1, then you would need pre-calc 2. But yeah, they say that you don't need it for that. So
Business, I got to take applied calculus and 213 business probability and statistics. And I just saw why I needed it. I was like, ooh, Lord Jesus.
Oh man, waiting for this thing to pull up. All right, let me see if I can find this book. Hold on, let's move it slow. Give me 1 second. Oh, there it goes. Oh, to say, like, what happened to my book? All right, so what page you say now?
Page 418.
418. Say that again.
I don't understand transformation.
All right, I'm there.
It's like I get it confused with using the reciprocal function on page 412.
Now, what are you trying to do?
I don't understand the part of how to do the points for the example.
All right. So now that's just graphing. Now let me ask you this. Did you see this in one of your homeworks?
It's in the book.
Right, but did you see it in one of your homework? I just want to make sure you're focusing on things that we're focusing on.
I did hold on. No, I haven't got to the homework yet.
Okay, because I want you to, because that's just graphing. And right now, we pros at graphing. There are other things I want you to focus on that are more important.
Okay.
Than graphing. Right. Yeah, because we graphing, we've been there, done that. And really, because if you want to graph, all you gotta do is plug in some points and then, get the, what I mean? Like, so we good with graphing, but there are other things I want you to focus on more than graphing. So that's why I didn't even talk about graphing when we were in that section.
Cool. All right, cool. I'm killing myself trying to figure out how to do each example.
Yeah.
And make sure I know the topic. Okay. I'm sorry for wasting your time on this.
No, ain't no waste of time. You got clarity. That's all that matters.
Thank you.
All right, not a problem. Is that it? You good to go?
Yeah, I got to watch the videos.
Uh-huh.
I'm starting 3.6 today. I got to watch. I got to do my homework. I got to watch the videos to understand all the concepts you've taught to be ready for the test for next Monday.
Yeah. And I saw your message. So yeah, I didn't get a chance to respond to it. So, but yeah. All right, cool. All right,
so,
then.
Let me get prayed up over the weekend. Oh, God. It got real, man.
Glad I could help, sir. I'm glad I could help bring you closer to God, sir.
God, you made me want to cry today. I was sitting here like, oh, Jesus, nah. The variations, I understand that's all business. You need to know the variation of your product being produced. And I'm like, oh, sorry. I'm just venting. I apologize.
All right, man. You have a good one.
do feel a little bit overwhelmed, but I'm all right.
Man, you're gonna be all right. I'm not worried about you.
All right, I'm sorry. I had to get that out. You have a good day, Professor.
All right, you do the same. All right, anybody else before we close? Everybody good? All right, everybody have a good one.